Yep.
Okay. So I decided that it makes more sense for the quiz tomorrow. I'm gonna give much more time. I think more time than you'll probably need. I'm just gonna give 3 hours. So from whenever you start, you'll have 3 hours to complete it. It's gonna be 6 questions. Yeah, and there are gonna be problems related to the dot product and the cross product. So if you guys want, um, I can review the potential topics that can come up, some potential questions and stuff like that. Or if you want, we can continue with what a plane is.
I personally would like to review some questions.
I agree.
Okay. One second. All right, 1 second. I think I went a bit too far. Okay, perfect. So yeah. So definitely everything from this part should definitely know how to calculate the distance between 2 points and to how to see that this is a surface, that this is a sphere, and that this is a cylinder. So definitely be able to do that. So these are the only real 2 surfaces that you need to know. So it's not that many surfaces. And then the magnitude of a vector, again, definitely be able to calculate that. And yeah, so for curves and lines, a question that can definitely come up, for example, is, 1 second, if 1 second. Okay, so while that's loading, the most important equation that you need to know for lines is this equation right here, or this equation, which is just the way it's written, the R0 plus T of the vector V, where the vector V is a vector parallel to the line. So definitely know how to write out a line. Now, types of questions that can come up, for example, I can have a line and a point. So let's say this is the point P, and this is the point Q on the line. Oh, well, sorry. You can have a line and a point, and I can ask you to find for me the shortest distance from P to my line. So this is my line. So that, for example, can be a question that comes up, and the way to do this problem is by finding a point Q on the line, which you do by setting T is equal to something. So you can take, for example, T is equal to 0. That can get you to Q. In this case, Q would be equal to your R0, right? So your line lines are written R of t is equal to R0 plus TV. So then your Q can be your R0, for example. And then you find the vector. So this is going to be the vector PQ. It's the vector from P to Q. So definitely know how to find this vector, right? It's going to be the vector Q minus P. And then you can look at the vector V. So now there's also a vector V on this line. So that's this vector over here, this vector V. And using these two vectors, for example, you can find this angle. That's one thing that you can do. So you can find the angle because you know that the angle is equal to cosine inverse of the dot product if PQ dotted with V over the magnitude of PQ times the magnitude of V. So you can find the angle. And then you can say that the height, that this over here, this height over here, so the height is going to be equal to the magnitude of PQ times times sine of this angle. And we know what that angle is. So then you have your height. So that's one way to find this height over here. Is this clear? This is, by the way, this is why sine would be used. You're projecting onto the y coordinate, and this over here is the magnitude of this vector. Yeah? Any questions about this?
If we choose to take the quiz later in the day, will you be available earlier in the day to take any questions or anything, or no? Will there be like no more questions after tonight?
Oh, I'm not going to pay attention to who's like taking the quiz and who isn't. So I would say that, yeah, tonight is like the last night for questions. Yes. Yeah, sorry. Any other questions?
Is it going to be a Canvas quiz format or just like a paper, like write it on paper and submit pictures?
Yeah, so it's going to be on Canvas, but it will be like you're going to upload pictures of the problems that you're doing. So you're going to just take a picture of the problem and upload it to Canvas. And it should be like 6 questions. And this question, for example, would be one. This would be the hardest, in my opinion, one of the harder questions. And it would be one question. For example, one of the questions might be, oh, find this angle. So now you just have to use this formula. So I might ask you to find the angle between two vectors. Another way to do this problem is by using the cross product. So we can also say that, like I wrote over here, H is equal to the magnitude of PQ times sine of theta, which is equal to the magnitude of PQ times the magnitude of V over the magnitude of V times sine of theta, which is equal, and we know that this over here is equal to the magnitude of V cross PQ over the magnitude of V. And that gives you H as well. So rather than do all of this, like rather than find this angle, you can also figure out, oh, I can use the cross product. If I take the cross product of V and PQ, which that's your PQ, then I'll get my h. Okay? Okay. So yeah, definitely know this equation for the line and be able to use it. Like, be able to find the line between 2 points for sure. If I give you 2 points and I ask you to find the line between them, you should be able to do that. Is that something that people feel comfortable that they're able to do?
Could we do an example?
Yeah. Okay. So let's say we have the point P, which is equal to 0, 1, 2. We have the point Q, which is equal to 1, 0, 1. So here are 2 points, and we want to find the equation of the line that goes through these 2 points. So the way we do it, again, the equation for the line is always R of t is equal to P of 0, some initial point, or sometimes, okay, I'm going to write this as R0, plus TV, plus t times the vector via vector, which is parallel to these 2 points. So basically what we're doing is we have a point P and a point Q, and we are finding the point R0. So we're pointing at one point on the line. So this, let's say, is the point R0. And then we're finding the vector V. And then that helps us find the line between these 2 points. This is basically what we're doing. This is a weird part of the picture, but it still makes sense. So we are pointing to our point R0, and then we have the red vector is our vector V, and it is parallel to our line, and it constructs our line. So in this example, we need to pick our R0. Let's pick that to be P. So let's say P is equal to R0. And then we need to find our vector V, and the vector V can be equal to the vector PQ. The vector going from P to Q, that's literally the red vector. So what is this vector? So this is the vector, and then you have 1 minus 0, which is 1, and you have 0 minus 1, which is negative 1, and you have 1 minus 2, which is negative 1. So then that's going to be your vector V. And so then your R of t is going to be equal to 0, 1, 2 plus, plus t of 1, negative 1, negative 1, which is going to be equal to, and then you're going to have this 0 plus t1, so you're going to have t here, and you're going to have this 1 plus, and then t, so minus t over here, and then you're going to have 2 from here minus negative 1 times t, which is t. Okay, and this is how your line is going to look. It's going to have this parametric equation. And so the x component is this. So going over here, we can say that x of t for your line is going to be t. Y of t for your line is going to be 1 minus t. And z of t for your line is going to be equal to 2 minus t. Yeah? So definitely know how to find the line between 2 points. It's going to be a reoccurring theme. We'll be able to we'll have to know how to do that. And also, if I give you a point and I give you the vector v, be able to find the line. So very basic stuff. Yeah.
Is R0 always gonna be one of the points?
Yeah, R of 0 is going to be P0, or R of 0, sorry. So when T is 0, then you're at R0. So you're here.
Okay. All right, thank you.
Okay. So definitely be able to tell if two different parametric equations do or do not parameterize the same line. So know that the V's would have to basically be the same or have to be parallel. And that if you then find one point from this line on this line, then we are dealing with the same lines. So it's basically, if you understand the geometry of these equations, you should be able to do that. So try to understand that. And definitely know how to find where two lines intersect, if they intersect, where they intersect. So yeah. So going through some of these problems, so definitely all of this stuff, the basic stuff about vectors, you should be able to do. So you can look over some of these problems. They're all fairly basic, I would say. And so, yeah, you should definitely be able to know how to figure out if two vectors are parallel or not. In fact, we know how to do that using the cross product as well. So that's another thing. Finding the unit vector in the direction u, finding the unit vector opposite in the direction of v. So yeah, those type of stuff definitely should be able to do. Definitely be able to say what a sphere at this point would look like and what a sphere at some other point would look like. Showing that these lines do not intersect. Yes, that is a question that so yeah, these type of questions. So try to do them if you feel uncomfortable with those type of problems, to see that you are able to do those type of problems. I will not ask questions with laser beams or stuff like that, even if they might be they might come fairly directly from the math. I'm just going to ask the math questions. So yeah, so those are most of those type of questions. And yeah, definitely know how to view a line. Like, what does this mean? How can I get my V out of this, and how can I get my P0, and how can I get another point maybe on the line? So yeah. Okay. So now, know how to take a dot product. Definitely very important. Know what a dot product can help you with. A very important part of a dot product is it helps with finding angles. So definitely be aware of that fact. And that comes from this formula. And you should definitely know this formula. So you definitely, anytime you want to find an angle, like I just showed in the other question with the height, right? If you want to find the distance between a point and a line, you need to know the formula that the angle is equal to cosine inverse of v dotted with u over the magnitude of v times the magnitude of u, where you're trying to find the angle between v and u. So if you want to find the angle between two vectors, dot product is very important. So know how to use that. Yeah. So a question like this, definitely very legitimate. Find the angle between two vectors. So being able to tell if two vectors are perpendicular is definitely important. And you should know that if they are perpendicular, their dot product is 0. So once again, a very important thing to know. So you should definitely be able to check whether two vectors are orthogonal by checking that their dot product is 0. Okay. Understanding the projection. So know the basic formulas for the projection. And I would even say, if you can, understand how we get them using cosine, how projections work, why projections are using the dot product, which it comes from cosine. But definitely you should know this formula over here. This is the most important one of the formulas, which is the component of the projection. So know that this is the component, u dotted with v over the magnitude of v, and then the unit vector of v. So definitely know this formula 100% and how to use it. There'll almost 100% be a projection problem. It's a very basic problem that we work on, and how to project u onto v, how to find the component of that projection. And at this point, we've talked enough about it that there might even be a orthogonal decomposition. So I can ask for, find the projection and find the orthogonal component of the projection and say that u is equal to both of them, show that u is equal to both of them or something like that. So definitely know how to do all of this type of stuff. Any like example 8, I would say take a second look at example 8. It is an important example, so you should know how to do it. Okay.
Will there be any conceptual questions like on the learning curve, or would you say it's just like math?
No, nothing conceptual. It's just like questions, like, yeah, with numbers and stuff. Yeah. So once again, know how to take the dot product, know this formula, definitely be aware of how that formula looks and how it's used. Know again how to decompose a vector, know how to get projection, know how to get the component of the projection. Yeah, so any questions about this? Okay, so definitely these type of problems you should be able to do, computing the dot product. So finding cosine of the angle between vectors, for sure, you should be able to do that. How to find the angle between vectors, definitely you should be able to find the angle between two vectors using the formula that we talked about. Even questions like finding a vector that's orthogonal to a certain vector might appear. Just try to find something such that its dot product with this vector is 0. It's generally not very hard. You can set even one of the components to be 0 and then get the two other components to cancel each other out. So I probably won't even ask it. So okay. What are the other types? So yeah, find the projection. Like I said, these type of problems might definitely appear. So any one of those problems, maybe do some of them to make sure that you can do them. Finding the magnitude of projections, those type of problems might appear for sure. Okay. Yeah, so I think that that's basically it from the dot product. Those are mostly the type of questions. And then from the cross product, definitely the torque. I might ask a torque problem. And it's the only real physics problem that might appear. Know what a determinant is. I might not necessarily ask directly, oh, take this determinant, find this determinant, but definitely know what a determinant is, because otherwise you'll just have problems for a while understanding how stuff works. And yeah, definitely know how to take the cross product, also very important. So you definitely be able to take the cross product between two vectors. Know that the cross product of the two vectors is orthogonal to both of the vectors. So, and also know that the length. So know that this formula, which connects the cross product with sine, looks exactly the same as the formula with the dot product, but with instead of cosine, we now have sine. So the cross product helps you in that regard. It does what sine does. It projects things onto the y axis. So try to use that fact. Know this formula and why it's true. Right hand rule is also very important. Obviously, all these formulas are very basic and very important. So they're all very important, but I don't know if there'll be a question that will require you using them, but they're not difficult enough that I mean, it should be very intuitive, I think, how to use a lot of this machinery. Yeah, so these type of problems definitely might appear. Like I can give you a force and I can give you a certain radius that it's being applied at and ask, oh, find the torque. It's just take the cross product. Definitely these type of formulas can appear. And definitely area problems. Be well aware of these formulas, that the area is the magnitude of the cross product of the two vectors if you want to find the area for the parallelogram, and it's for the triangle, it's that same exact thing divided by 2, because you want to find half of it. So yeah, know these two formulas, and yeah, know what the scalar triple product is and how it relates to the area of a parallelepiped. That's really the only place we're going to use it, like I said. And it actually is just the determinant of u, v, and w. So I might ask you like, oh, what's the area of this parallelepiped? And that might be a question. Or I might ask, oh, what's the area of this triangle? Or something like that. So definitely be able to find those type of areas. And yeah. So example 7, for example, is very important, being able to find the area of a parallelogram or parallelepiped. So yeah, all this type of stuff, the computation over here, what a cross product is, important things, that it's orthogonal, all this should be very intuitive at this point. The fact that v cross w is equal to 0 if the two vectors are parallel, you can use that to figure out if two vectors are parallel. So if you're asked a question like that, that's basically what you want to look at. This formula for the area of a triangle, the formula for the area of a parallelogram, both very important. What the scalar triple product is, and how it's used for parallelepiped. Again, it's just the determinant of u, v, and w. So if you remember that, it should be okay. So definitely these type of questions, find the cross product. What is U cross V, assuming the W, sorry, what is U cross W, assuming W cross U is equal to that. So those type of stuff you should definitely be able to do. Calculate V cross W. So these type of questions, definitely be able to do these type of problems. Any questions about this? So also these type of questions, calculate the volume of a parallelogram, calculate the volume of a parallelogram, sketch the triangle, and calculate the volume using the cross product, right? So yeah, you just take the vector between these 3 points and the origin, and you use them to create 2 vectors. You find the cross product, you take its magnitude, and you divide it by 2, right? So these type of questions, we've seen these formulas, definitely should be able to do these type of problems. Okay, and that's basically it, I think. I don't think there's going to be that much more. So that's basically what the quiz is going to be on. Any questions about this?
Could you go back to the scalar triple product?
Mm-hmm.
I just didn't write the equation down.
And obviously all of this is just in the textbook, and we're just looking through it, so it should be fairly easy to review. But yeah, it's this over here.
So the quiz is just covering 12.2, 3, and 4 in the textbook, basically.
Sorry?
Is the quiz just covering 12.2, 3, and 4?
Yeah, I'm not 100% sure what the first section is. I think it's it basically starts from the first section that we started and it finishes with this section. So that's basically what the quiz is. So we started with like what a vector is, and obviously topics in that section are on the quiz. I'm not going to necessarily ask for that question, like, oh, find a vector between 2 points, but in order to find the area of a triangle, you definitely might need to find 2 vectors between 2 points, and so you might need to, you know, find those vectors. So yeah. And then the quiz is up until this section. Any other questions?
I have a question. Will this lecture be posted?
Yeah, I'm gonna also try to post the last one. It just takes a little bit of time sometimes. I apologize.
Okay, thank you.
Okay.
Hey, how long is the quiz? Or how long do we have to take it?
So I'm just gonna give you like 3 hours, which I think should be enough time. So I don't think you're gonna need all of it. It's going to be like 6 problems. So one of the problems might be find the projection or decompose the vector into its projection into its orthogonal component. So I think a problem like that should take like 20 minutes, probably 25 minutes. So I think like 2 hours should definitely be enough. So I'm gonna give like 3 hours, which I think should be okay. One of the problems might be like, oh, find the angle between two vectors. And a problem like that should take like less than 10 minutes, I think. It's basically like, oh, cosine inverse of the dot product over the magnitude. I might ask to find the area between 3 points. So that's basically, you have to construct a triangle, which probably takes like 4 minutes, and then you take the cross product, which probably takes like another 4 minutes, and then you take the magnitude, which might take 2 minutes. You can use a calculator, I'm fine with that. And then you divide by 2. So it shouldn't take too long. Okay.
How much work should we show? And if it's like finding an angle, are we allowed to round, or do you want like exact answers?
Show all the work, and no, you can leave it as the angle of cosine inverse of whatever, and then use your calculator and say, oh, it's approximately 19.1, and that's fine. So yeah.
Thank you.
Hey, when's the quiz gonna open?
Sometime in the morning. I don't know. I'm gonna try to do it as early as I can. So yeah. And then you're basically gonna have the whole day, and yeah. So just try to make sure to do it sometime during the day.
Is it posted up yet, or do you stop do that?
I put up the questions. I just have to like send it. I have to post it. Yeah, I have to publish it. Yeah.
Right.
Okay. Okay. So let's continue with what a plane is. Okay. So when we have a plane, it's always written in the form ax plus by plus cz is equal to d. So this is how we write a plane. It's the x over here, nothing is squared. You have just a coefficient in front of the x, coefficient in front of y, coefficient in front of z is equal to d. That's the general form for the plane. And you can read out certain pieces of information about the plane from this over here. And what you read out is that the normal vector is of this plane is equal to a, this coefficient for x, b for y, and c for z. So it's actually very nice. And what this means is that if I were to look at my plane, so here's my plane. If I were to look at it, and I were to look at this vector, the vector n, here's my vector n, it would be orthogonal to the plane. So 90 degrees from the plane, which is very nice because that it tells us a lot of information about the plane. Any vector that lies from this point over here in the plane to some other point in the plane, if I took the dot product of that vector with this normal vector, with this vector over here, it will be 0. So there's a lot of information suddenly that we get from this n. So that tells us about what these coefficients are doing, and they're very important. And then this coefficient is also fairly important. There are a lot of normal vectors to this plane. There are a lot of n's. There is a normal vector looking like n down here. There's one over here. So in order to know which exact plane we're dealing with, this d, it tells us that there are different ones, and there's one here, and there's actually one coefficient that determines those, and that's d. It gives you it tells you among the stack, for example, of planes that have this type of normal vector, it tells you which one we're dealing with. And in this case, we're dealing with this one, we can imagine. So that is what these different pieces mean. If we wanted to figure out how we can show that this is the formula of a plane, we would look at the following thing. So let's try to find let's try to solve the following equation. We're going to look at the normal vector, and we're going to dot it with the vector x minus x0. So what is, let's imagine that this point over here is the point x0, y0, z0. And let's imagine that this point over here on this vector is the point x, y, z. So you see, these are all the points. As I move around these points on the plane, I get all the points on the plane. So these are all the points on the plane. And they're in fact this x, this y, this z. And this is one single point on the plane. It's some fixed point on the plane, x0, y0, and z0. And I am looking for all the vectors such that this vector going from this point to this point, so that's why it's x minus x0, so on, dotted with n is going to equal to 0. So it's going to be x minus x0, y minus y0, z minus z0 is equal to 0. So I'm looking for all of these points. So this is with this x, this y, and this z. So those are all the points on the plane. Yeah, is this okay? Any questions? So now the point N is the point A, B, C, dotted with x minus x0, y minus y0, z minus z0 is equal to 0, which tells me that ax minus x0 plus by minus y0 plus cz minus z0 is equal to 0. So now, let me just erase this for a second. So now if I distribute, I get that this says that ax minus ax0 plus by minus by0 plus cz minus cz0 is equal to 0. So that tells me that ax plus by plus cz is equal to ax0 minus by0 minus cz0. So this over here is the equation of my plane. So that's that part, and this over here is my d. So in fact, if you want to find this d over here, there's always a very simple way. You can, oh, 1 second. Is this supposed to be plus? Yes. You can always plug in x0, a point. You can always choose a point that you're supposed to be on the plane. Let's say you have the normal vector and the point that's supposed to be on the plane. You can always take that point, plug it in over here at x0, y0, z0, and you'll get your number d. So we will do problems like that. In fact, I think we should do one problem like that, and that's how we're going to end. So let's imagine that you're told And next week, we're gonna just start again with the plane and continue from there. Are there any questions about this? Okay, so let's say you're given a normal vector, 3, 1, 0, and you're told that there's a point on the plane, P0, let's say, which is the point 0, 1, 0. So that's a point on the plane, and they tell you find this plane, find this plane. So you can say, okay, so I'm gonna have 3x plus 1y, so plus y, plus 0z. So let me actually change this 0 just so that we get to see what z is doing. So I'm going to change this to 2 plus 2z. Okay, I know that this is equal to d now because this is my normal vector. So this is the first part of my plane. So it tells me how this side of my plane looks. Now I want to find my d. Okay, well, I know a point on my plane. So let me plug it in to this and see what happens. So that's going to be 3 of this point of my x, 0, plus y. Oh, what happened? Oh, yeah. Plus y over here times 1. So 1 plus 2 times 0. That's going to be equal to my d for this specific point, because this point lies on my plane. So we know that this point satisfies this equation. So, well, this is 1. So then d is equal to 1. So this is the equation that will satisfy that this is its normal vector and this point lies in it. And actually it does. If I put a 0 here and a 1 here and a 0 here, I get 1. So okay, so I think we're going to stop here. Are there any questions?
How did you get d equals 1 again?
So you just take the point. So if I have a point, you see they tell you that this point it lies on the plane. So if it lies on the plane, it means that whatever d is, if I plug in this point to this plane, I am going to get a certain number here. And that number will be whatever d, that number will tell me d. Because I have to satisfy that this point is on the plane. So I have to satisfy that if I plug this point into here, if I plug 0 for x, 1 for y, and 0 for z, I will get a number. That number is d. So for example, if I change this for a second, so if P0 is equal to, let's say 5, 2, 1, then now in order to find d, well, I know that P0, I know that d, I mean the plane contains P0. So that means that if I take it, I know for a fact that if I take 5 of these, if I take 5 x's plus 2 y's plus 2 z's, I will get a number that is, on the plane. I'll get a number on the plane. And I know that this number is d. So now I know what d is.
Okay, thank you.
Yeah. Any other questions? Okay, so I think we're gonna stop here. And yes, have a nice